All right. So the last two videos, we kind of set the foundation for this one. We learned the pieces, we figured out what was going on. This is where we put it all together now, and I show you how easy graphing absolute values can actually be. The rules that we've kind of established in the last video, this left, right, up, down stuff right here, is one of the most important things I will ever teach you in Algebra 2. The reason this is such a big deal is these rules right here, the inside left right, the outside up down, those rules work on every kind of graph we will talk about in Algebra 2. So in a couple of weeks from now, a month from now, I'm going to be talking to you about parabolas, x squared, and these same rules are going to work. It's going to be the same thing with cubic graphs, with logarithmic graphs, with square root graphs, with everything I'm ever going to teach you in Algebra 2. These rules can apply. So it's really important that you have this memorized right here. And let me show you it through a few examples, how it makes your life a lot easier. So I'm going to ask you to graph this right here, absolute value x plus 3 with a minus 5. And you could make a table and you could plug in numbers and it would take a little while, but you could do that. But it's actually really easy if you understand your rules. What I'm going to do is label up on this picture what direction it's going to move. This plus 3 right here is on the inside. The add subtract number on the inside is left right. It does the opposite of what you would think. So a plus 3 actually moves me left 3 units. And a minus right here, this minus 5, the outside is up and down, and it's normal. So I'm going to go down 5. So this picture needs to move left 3, and it needs to move down 5. So let me adjust my view right here, and let's talk about that. We already learned that the basic parent function for absolute values starts right here at 0. That's where the vertex was supposed to go. But my picture needs to move left 3 units. So I'm going to go left 3 tick marks, and I'm also going to go down 5 tick marks. Sorry, my picture's a little wobbly here. I go left 3 and I go down 5. That means this dot right here is going to be my vertex. So this says left 3, this says down 5. Vertex used to be here, now it goes here. The number I am multiplying by in this problem is a positive 1. Positive 1 is like the slope for my absolute value. So from my vertex right here, I'm going to go up 1 over 1. I'm going to get a point right there. The thing about it is it's absolute value, and absolute value makes a v. So I not only go up 1 over 1 this way, but I go up 1 over 1 the other way. And I get another dot right here. You could go up 1 over 1 again and again. These 3 dots are a minimum of what I need to see. So then I can just go ahead and I can graph my v using those 3 coordinates. So the vertex of this picture is at -3, -5. I got that just by looking at my picture right here, -3, -5. The axis of symmetry would be this line right here. It's always x equals because it's vertical. And that happens at x equals -3. It's always going to be the x from your vertex. So x equals -3. Domain, the graph goes left, the graph goes right, arrows go both ways. For absolute value graphs, this is going to be like a free point. The domain is all real numbers. And the range, the y's on this picture, are everything from this line and above. So it's going to be y, it's going to be greater than or equal to, and the y where I marked it is at -5. It's always going to be the y from your vertex. So you guys can see that this really isn't so bad. And let's go even faster through the next one. Inside is left, right does the opposite. This is going to go right 4, and it's going to go up 1. So my first job right here is to go right 4 and to go up 1. So right 4, up 1. Boom, that's where my vertex ends up. This time I have a positive 2 that I'm multiplying by for my slope. So my rays are going to go up 2 over 1. I'm going to get like a skinnier, narrower looking absolute value this time. Up 2 over 1 both ways. And then I'm going to go ahead and draw my picture. These are so fast and quick once you know your rules. Vertex on this picture is 4, 1. Axis of symmetry is x equals 4. Domain, all real numbers. And my range is going to be y. It's greater than or equal to a positive 1. So not so scary once you learn the basics. Why don't you see if you can try this third one for yourself right here? You can pause the video if you like, but I'm going to talk about it momentarily. So pause it if you want to try it for yourself. This graph is going to go left 6 units. I have a positive 6 that moves me the opposites. I don't have an up or down number over here. That's because there's really a +0 that I don't see. So I go left 6. I do not go up or down. That is my vertex right there. I have a -3/1 for my slope. So what I'm going to do from my vertex is I'm actually going to go down 3/1 units. Negative absolute values are upside down v's. So I go down 3/1 this way. This is still my vertex, so I go down 3/1 the other way. And I'm going to get a graph that looks something like this. So the vertex on this picture is -6, 0. My axis of symmetry is x equals -6. Domain all real numbers. And the range on this one, the y's on my picture are all below 0. If you have an opening down v, you're going to have a less than or equal to instead, and it's going to be 0. So negative graphs have a less than or equal to on their range. The last graph I have right here is a little more complicated, and it's kind of crazy looking. This 2 is not a slope, it's just a 2 sitting here. This is the same thing as having a +2. So that is actually my up and down number right here if you just have a 2 hanging out. I don't have a number on the inside with x. It just says absolute value of x. So I do not go left and right. I only go up 2. Now you might be wondering, like, what is that 4 doing right here? When you divide by a number, that's part of having a slope, a number that you're multiplying by. This is the same thing as having a 1/4 for your slope. Absolute value of x over 4 is the same thing as 1/4 times absolute value of x. And because there's a minus right there, it's actually a -1/4. So what I'm going to do here is I'm going to go down 1/4. Down 1/4. I end up getting dots here and here. So I get a really wide looking upside down V. I missed my dot right there, sorry. So my vertex on this graph, 0, 2. Axis of symmetry, x equals 0, domain all real numbers, and range is going to be y is less than or equal to 2. After you learn your rules, these really aren't bad to do. I have one final disclaimer and we are done with this section. Every single graph I've done so far has had y equals with just a regular x on the inside. Let's say I did something like this, where there was a 2 in the front. As soon as you see a number on the x, you can't use translation rules. I'll say that again. When you have a number on the inside with x, you're not allowed to just count it out. This graph does not go right 6, okay? You have to make a table or use your calculator if you have more than just x going on. So if you see a number on x on the inside like this, all bets are off. You cannot just count this out. You have to make a table instead.